Hello, the subject of this video is factoring quadratics of the form ax squared plus bx plus c. These are different in that the coefficient of the x squared is not a 1, it is going to be something other than 1, a. Now you'll remember when you multiplied binomials, you did the first times the first, these first two coefficients got multiplied. They actually became the a in this quadratic. Then you did the outer ones and the inner ones, multiplying them. The sum of those, because they ended up being like terms, became the b value. And then you would multiply the two numbers on the ends here, the last ones, and the product of those two would end up being the c value in your quadratic. So when you're looking to go from the quadratic to the two binomial factors, you're looking for something that's going to, the a value is going to be the product of these two leading coefficients. The c value is going to be the product of the two end constants. And the b is going to be a sum of the inner and outer products. So what you need to do for something like this example here, 2x squared plus 15x plus 18, is you need to list all the factors of a, list all the factors of c, find the combinations, multiply the combinations of those outer and inner factors there, all those combinations, to see which one matches up with your b value. So here I have a coefficient, an a value of 2. The factors of 2 are simply 1 and 2. There are no different ones other than 1 and 2. It's a prime number, so that's the only factors it's got. 18 has factors 1 and 18, 2 and 9, 3 and 6. Now, since we are talking about position being important here, I could switch these around and end up being 6 and 3, 9 and 2, 18 and 1. Now, the way I've set this up is if this is the first factor, that's our first coefficient of the first term of the first binomial, this is the first coefficient in the second binomial, and this would be the constant in the first binomial and the constant in the second binomial. So when I do the check for the outer and inner sums, I would do 1 times 18 to get the outer. The inner would be the 2 times the 1. And when I add those two together, here I get 20. Then I did 1 times 9, the outer, and 2 times 2, the inner. Add those together, I get 13. And you keep doing that through all the different combinations until you find one that happens to be, this one here, happens to be the b term, 15. So this one, the correct terms are going to be the 1 for the first binomial for the coefficient of the x, 2 for the second coefficient of the x over here, and then we have 6 in the first binomial, 3 in the second binomial. These are this is your factor binomial, and to check it, you would do the multiplying. X times 2x gives you 2x squared. X times 3 gives you 3x, 6 times 2x gives you 12x, 12x plus 3x gives me 15x, and 6 times 3 gives me the 18. Now, if you think that's bad, a lot of work there, think about this. That first coefficient was a prime number. Here we have a factor on the x squared here, we have a coefficient of 4, which has more than one factor there. It's not just the 1 and 4, it's also 2 and 2. And the factors of c, here 42, I've got 1 and negative 42 because it's a negative number, 2 and negative 21, 3 and negative 14. I got a huge list of factors. I could end up doing this sum for hours. Well, there is another way. Another way is called the AC method. And this is not in your textbook here. The AC method says, step 1, take a factorial trinomial of the form ax squared plus bx plus c, and multiply the a and c values, the coefficient of the x squared and the constant at the end. Multiply those two together. And the product of the a and c are now going to become your new c, and you're going to drop the a. Let's see what that looks like. This is just step 1 here. If we're given this, my a value is 6, my c value is negative 12. Multiply 6 times negative 12, and I get negative 72. I'm going to make that my new c value, and I'm going to get rid of my a. So this becomes x squared minus x minus 72. I've replaced the 12, the negative 12 with a negative 72, and I've gotten rid of the 6. That's step 1. Step 2, factor the resulting quadratic. Now that we have a coefficient of 1 on the x squared, we can factor this with our normal process, drawing the two sets of parentheses, putting an x here and an x here, asking ourselves what multiplies to give us negative 72, but adds to give us negative 1. Well, I think 9 times 8 is 72, and since we are talking about a negative, we have to have opposite signs. One's going to be positive, one's going to be negative. Since the middle is negative, the larger factor is going to be negative, which is 9. And when I check, 8 times negative 9 is negative 72. 8 plus negative 9 does give me the negative 1. So that's step 2. Step 3, we replace the x with ax. And I did flip-flop these, but that's okay. So I'm going to replace the x with ax. Wherever I see an x in here, I'm now going to make it ax minus 9 and ax plus 8. But it's not a, is it? A was originally a 6, right? So we're going to put in 6x, not a, but replace it with the original a value in front of the x there. Step 4, factor out any common factors from the binomials. Here I've got 6 and 9. There's a common factor there of 3. So when I factor that out, I'm going to divide both of these by 3. I get 3x minus, sorry, not 3x. 6 divided by 2 is, 6 divided by 3 is 2, not 3. 9 divided by 3 gives me 3, so I get 2x minus 3. Here I would factor out a common factor of 2, which is going to give me 3x plus 4 over here. Step 5. Multiply the constants that were factored out. If the product equals a, the original a, which in this case was 6, remove the common factors, and you have your factored quadratic. 3 times 2 is 6, which was our original a value. So I'm going to remove those, and I'm left with 2x minus 3 and 3x plus 4. To double check your answer, and you should always double check your answer, you would distribute to do the multiplying here. So we take that 2x minus 3 and a 3x minus 4. 2x times 3x, 6x squared. 2x times negative 4 is negative 8x. Negative 3 times positive 3x is negative 9x. And negative 3 times negative 4 gives me a positive 12. And going back, where am I missing something here? I messed up somewhere here. I gotta stop. What did I do wrong? 6. Oh. This is a positive 4. So 2x times positive 4 is a positive 8x. Sorry about that. 8x and 9x, when they combine those, are going to give you negative x. So you end up back at the original given of 6x squared minus x plus 12, the original given. So this is the correct factoring of that trinomial. I do have another video where I will go through the proof on this, and I hope to make another video where I go through some additional examples. Thank you.